All right, in this video, we're going to be going over engineering economics. All right, and we'll just cover a few of the most major topics. So we'll be talking about cash flow, and compound interest, and annual deposits, and annual withdrawals. All right, so let's go ahead and just jump right in. So first thing we want to talk about is cash flow. And this is just how much money you're bringing in versus how much is being spent. All right, so we actually can use what's called a cash flow diagram to kind of make a visual representation of our cash flow. So what these look like, there's going to be a line, and this is just kind of depicting time, right? So once we have that, we'll have certain arrows that either go up or down. And the arrows that are pointed upwards dictate positive cash flow. So that's going to be money that's being brought in or money that's being made or profit. And then arrows that are pointing down is going to be money that's being spent or being given away, but it's going to be negative. So each of these arrows would have a time associated with them. So time period 1, time period 2, time period 3, time period 4. Sometimes this starts at time period 1. Other times it starts at time period 0. And then this would be time period 1, 2, 3. And it doesn't really matter what you start at, just as long as you know what's going on in your particular cash flow. I like to start at time period 1, personally. But again, you might see things differently on an exam or something like that. But if we had, for example, a cash flow that looked like this, all right, and we wanted to find, and let's say we're starting at time period 1, and we wanted to find the cash flow at time period 2. We would just add up time period 1 and time period 2. But remember, time period 2 is negative, so we're going to have 500 minus 100, and that would be $400 positive for that particular cash flow. Now, if we wanted to find it at T4, we just add all the time periods up. T1 plus T2 plus T3 plus T4. Remembering that when the arrows point down, we're going to use negatives numbers. So we're going to have 500 minus 100 minus 100 minus 100, which will equal $200. So over this whole time period, you're making a profit of $200. All right. So go ahead now and try on your own this particular cash flow. All right, again, we're going to start at time period 1. And find cash flow at T3 and T5. All right, so go ahead and pause the video. And you can check your answer with the PDF found below this video. Work that out, and then we'll move on to the next section. All right, so next thing we want to talk about is compound interest. So this is going to be used when you deposit a certain amount of money into a bank at a certain interest rate, and you want to know how much money is going to be in that account at n years from now. So the equation we use is going to be our future worth is going to be equal to our present worth, or the amount, or our principal, or the amount we're depositing, times 1 plus our interest rate raised to the number of years that money is going to be in that account. Now, one thing to note is that whenever we use I, we're using the decimal version of our interest. So for example, if we had 10% interest rate on this account, we would turn this percent into a decimal before we insert it into our equation. So we would just move our decimal 2 places to the left. So we'd go 1, 2. So it's going to be 0.10. And this is what we're going to use in our equation right here. So, for example, if we deposit $10,000 into an account that has an interest rate of 5%, and we want to know how much money will be in the account after 10 years. All right, so we want to know the future worth when we deposit $10,000 into an account with a 5% interest rate. So we've got to turn this into a decimal. So again, just move it 2 places to the left, 1, 2, 0.05. And we want to know how much will be in the account after 10 years. So that n in that equation always represents number of years. So I can write that up here. N equals number of years. All right. So you just plug all that into a calculator and you'll get 16,288.95 All right. So go ahead now and try this one on your own. If you deposit $20,000 into an account with an interest rate of 5%, and you want to know how much is going to be in there after 30 years, and it's compounded annually. So find future worth. Let's go ahead now and pause your video. Work that out and check your answer with the PDF found below this video. This will be number 2 in that PDF. All right, so the next thing we want to look at are annual deposits. So this would be like if you take a certain amount and you deposit it every year, and interest is being earned on that account as you deposit a certain amount each year. So the equation we use would be our future worth would be equal to the annual amount that we're depositing into this account each year. So again, you're taking an amount and you're depositing it each year. So every year, a certain amount, A, is being put into this account. And you're going to multiply that by 1 plus your interest, raised to the number of years, minus 1, all over your interest. All right, so for example, if we had if we were depositing, $100 every year into an account that earned 3% interest, and we did this for 30 years, how much would be in the account at the time of 30 years? So again, we're depositing $100 every year into an account that's earning 3% interest, again, using interest in decimal form. We're doing this for 30 years. So you plug all that into a calculator and you'll get $4,757.54 at the end of 30 years. All right, so now go ahead and try on your own. If you every year made an annual deposit of $500 into an account with an interest rate of 8%, and you accumulate money for 15 years, how much money will be in there at the time of 15 years? All right, so go ahead, pause your video, run the numbers on that, and check your answer with the PDF. So it'll be number 3. All right, and finally, we're going to look at annual withdrawals. So this is kind of the opposite of annual deposits. So instead of putting money into an account every year, this is when you're going to have a certain amount starting in the account, so a present worth, and each year you take out or withdraw a certain amount of money. All right. So every year you're taking money out of your account, and that's going to be the same amount every year. Okay. And so you can use this to figure out how much money needs to be in an account and then how long it'll last. All right. So the equation for this is going to be present worth is equal to the annual withdrawal amount times by 1 plus our interest, again in decimal form, raised to the number of years we're making these annual withdrawals, minus 1 all over interest times 1 plus interest raised to the number of years. All right, so for example, if we had an account with a certain amount of money in it, and the interest on this account is 7%, and every year we withdraw $1,000. All right. And we do this for 15 years, and it leaves nothing in the account. We want to find how much money was in the account to begin with. So that present worth. So again, we're going to have present worth as being equal to our annual withdrawal times 1 plus our interest, again in decimal form, raised to the number of years, minus 1 all over our interest times 1 plus our interest raised to the number of years. All right, and when we do this, we get $9,107.91. All right, so that's how much money was in the account to begin with. All right, so go ahead and try on your own. Again, if there is a sum of money deposited into a fund with an interest rate of 10%, and if annually you withdraw $500, and you do this for 10 years, how much money was in the account to begin with if nothing is left after 10 years? So again, find present worth. You can go ahead and work that out. Check your solution with the PDF. This will be number 4 on that PDF. And that concludes what we need to learn about engineering econ.